Okay, 8.7, volume with cross-section, squares and rectangles. Okay, a region is bounded by y equals x over 2. So on this graph, that would be the line. And y equals the square root of x, which would be this. This should not be here. And forms the base of a solid. For this solid, each cross-section perpendicular to the x-axis is a square. Okay, so this is going to form a 3D solid. I'll show you a picture in class. So this is the base of the solid. It's going to kind of stick out of your paper. It's perpendicular to the x-axis, each cross-section, which means I'm going in this direction. It also gives me a hint that we're going to do dx. And each cross-section that sticks up is going to be a square. So it's kind of going to like be a bunch of squares like this. This is not, 3D doesn't work the best down here. Okay, there's a square here, there's a bunch of squares, and it's going to make a 3D solid. Okay, we want to find the volume of the solid. To find the volume, we're going to integrate the area of each cross-section. Okay, for a square, because this is a square, how do you find the area of a square? Yeah, just the side times itself, so side squared. Okay, so we're going to find the volume. To find volume, we're going to integrate the area of the square. Since I am perpendicular to the x-axis, I'm differentiating with respect to x, so my boundaries with respect to x are going to be x equals 0, 2. It looks like x equals 4. If I wasn't sure, I could set the two equations equal to each other and solve. And then I want the side of the rectangle squared. The side is this cross-section right here, from here to here. So if I want the distance from here to here, I'm doing this upper function and I'm subtracting the lower function. The upper function is the curve. The curve is the square root of x. Minus the lower function is the line, which is x over 2. And I'm squaring it because it's the cross-section is a square. And then I'm doing this with respect to x because it's perpendicular to the x-axis. Okay, this is the setup for my problem. I'm going to put it in my calculator. Before I put in my calculator, I'm going to mention one thing. For this distance right here, I did square root of x minus x over 2, so it would give me a positive value. If you swap these, because it's being squared, it's going to turn positive anyways, so it's not going to affect the outcome of your equation, and it's equivalent. So in this case, it actually doesn't matter the order of these two functions. Okay, let me go ahead and put this in my calculator and get an approximation for the volume. Okay, for the volume, I got 0.5333. It does not ask me for units, so I would not put them if they didn't ask, but if they do ask, since they're not indicated, this would be units cubed, because volume is cubic. Okay, so this is the general formula for the volume of a solid with a known cross-section. The volume is going to be the integral from a to b of a to x dx, where a of x is the area of the cross-section, which in this case was the area of the square, perpendicular to the x-axis. Because it's perpendicular to the x-axis, that told me that this was going to be dx, and it also told me that the boundaries were going to be the x boundaries. Okay, let's look at example 1b, which will be very similar. Okay, example 1b, a region is bounded by y equals x over 2, just like the previous problem. It forms and y equals the square root of x, it forms the base of a solid. For this solid, each cross-section perpendicular to the y-axis is a square. What is the volume of the solid? Okay, so we're still doing a square. It's the same two functions. The only difference is now we're perpendicular to the y-axis, which tells us first that we're going to be dy-ing. And if I'm perpendicular to the y-axis, each cross-section is going to go in this direction. Okay, and then it's going to form some kind of square sticking up. Okay, since I'm going to be perpendicular to the y-axis, and I'm doing this with respect to y, I need to solve all the equations in terms of y. So that's what I'm going to do first. So my first function was y equals x over 2. If I solve for x, I can multiply by 2, so I get x equals 2y. Okay, now let me look at the second equation. The second equation is y equals the square root of x. I'm going to square both sides, and I'm going to get x equals y squared. Okay, now I have both functions in terms of x. So to find the volume, okay, I'm doing with respect to y, so I'm going to look at the y boundaries. The lowest y value is 0. the highest y value is 2. So I'm going from 0 to 2. And again, if I did not know what the boundaries were, because they didn't give me the graph, I would set these equal to each other. Y squared equals 2y minus the 2y, and I would be able to solve for the 2y boundaries. Okay, since I'm doing a square, the formula for a square is the side squared. This is the side is the cross section. So the cross section is the distance from here to here. I'm going to do this minus this, so I get a positive value, although because I'm squaring it, it's not going to make a difference. Okay, so the furthest to the right function is the line. The line is 2y minus, and then the closer function is the y squared. And then because this is a square, I am squaring it, and I'm doing this with respect to y because it is perpendicular to the y-axis. Okay, I'm going to go ahead and calculate this in my calculator and see what I get. Okay, I put it in my calculator, and I got approximately 1.0666. I truncated instead of rounding. It's up to you. It doesn't ask me for units. They would be some kind of cubic unit if it asked. Even though these were the same equations, I did not get the same answer because the solid, when I make the squares in this direction, ends up being larger than if I do it with perpendicular to the x-axis. Okay, what is this? This is squares and rectangles, so let's try a rectangle. Okay, example 2. The base of a solid is bounded by y equals x to the third, which is this function here. Y equals 0 and x equals 2. Find the volume if the cross sections taken perpendicular to the x-axis, already the perpendicular to the x-axis is telling me that we're doing this with respect to x, form a rectangle, that tells me what area formula I'm going to use, whose height is twice its width. Okay, let's try this. Volume equals, okay, I know I'm going with respect to x because it is perpendicular to the x-axis. So in the x direction, I'm going from 0 to 2. Okay, now what am I doing? I'm doing a rectangle. The formula of a rectangle is normally like the base times the height or the length times the width. It's one measurement times the other measurement. Okay, now the first measurement is always going to be the cross section. Since I am perpendicular to the x-axis, my first cross section is going to be from here to here. Okay, so what is this? This is x cubed minus 0. So the first side of my rectangle is x cubed. Now what about the second side of my rectangle? It says the height is twice the width. I don't care which one's width, height, base. It means it's twice the other side. So the first side was x cubed. The second side is going to be twice x cubed. So it's going to be 2x cubed. Then since I'm doing this with respect to x, it's dx. That's my setup. I'm going to go ahead and solve this. I'm going to put it in my calculator, so if you would like to put it in as it is, that's fine. If you want to simplify it, you can. The reason to simplify it would just be to make it easier to type in your calculator. So this would be 2x to the 6th dx, okay? Not necessary to simplify it if it's a calculator problem, but if it's helpful to do so, then go ahead and do so. If I were solving this by hand, I would 100% simplify it because I could easily integrate from there. So when I put it in my calculator, I get about 36.5714. 4 decimal places, please. Truncate around is fine. Okay, one more example here. Okay, find the volume if the cross sections taken perpendicular to the y-axis form a rectangle whose height is 6. So it's the same figure, same functions. Since I'm doing perpendicular to the y-axis, I do know this is going to be dy, or respect to y. Let's just try it. Y-axis. So I have my equations. Oh, but they're not solved. So let me solve them real quick. No, let me just start it. Okay, volume equals. Since I'm with respect to the y-axis, do I see the boundaries? The lowest y value is 0. The highest one looks to be 8. Let me see if that makes sense. So y is 0. That makes sense. The highest y is going to be when x is 2. So when I plug in 2, I get 2 cubed, which is 8. That makes sense. Okay, now the cross section is perpendicular to the y-axis. So I know the first side of the rectangle is going to be in this direction. So I want to do this minus this, but I want it to be in terms of y. So let me solve. Y equals x cubed equals x cubed. If I cube root both sides, I get x equals the third root of y. Okay, now let me, again, look at this side. So my cross section says I want to do this equation here. What is this equation? That's x equals 2. So I'm going to do 2 minus the curve. The curve is the third root of y. Okay, this is a rectangle. So one side is this side. What's the other side? The height is 6. Okay, so the other side is just 6. With respect to y, because we're perpendicular to the y-axis. So it's a rectangle, so it was one side times the other side. This is my setup. This is a calculator problem, so I'm going to go and put it in my calculator. I get about 24.00000, or 24. Okay, last example, no graph given. Okay, the graph of y equals x squared minus 4 and y equals 2x minus x squared create a bounded region that is the base of a solid. This solid has cross sections that are perpendicular to the x-axis, first important information, and they form squares. Find the volume. Okay, so I already know perpendicular to the x-axis, I know it's going to form a square. So let's go ahead, I'm going to go ahead and start setting it up. I'm going to set it up on the right. V equals, okay, now I want to integrate. I'm doing it with respect to x, so I need to figure out where the x value is where these two functions intersect. So I'm going to go ahead and set this equal to this to see when the two graphs meet. Okay, since the x squared on the left is already positive, I'm going to move everything to the left. So if I plus x squared, I get 2x squared. If I minus 2x, if I minus 4 equals 0, your equal 0 must be there, or the zero product property doesn't work. Okay, I need to factor this. Since everything looks like it's divisible by 2, you can divide everything by 2, or you can factor out the 2. This is just to make it easier. You could also factor it from that step. This does make it easier. So this is x minus 2, x plus 1. So x equals 2 and x equals negative 1, which means my x boundaries are going from lower limit of negative 1 to positive 2. Okay, now these form a square. The formula for a square is a side times itself. So I just need this side. The side is the cross section. Okay, so I want to do this one minus this one, or this one minus this one. Now technically, because I'm squaring it, it's not going to matter which one comes first. Because it matters sometimes, I'm going to go ahead and see which one is higher, just for the practice of it. To see which one's higher, since I don't have the graph, I could pick a number between negative 1 and 2. Let's go with 0. If I plug in 0, I get y equals 0 minus 0, which is 0 for that function. For this function, I get y equals 0 squared minus 4, which is negative 4, which means this one is higher. Okay, so I'm going to do this one first, minus the other one. Make sure you put the other one in parentheses when you're subtracting. And then because of this is a square, it's the cross section squared. Okay, now if this is a calculator problem, there's no need to simplify it unless it is helpful for you to simplify it. I'm going to simplify it because I would rather type a little bit less in my calculator. So 2x minus x squared. If I minus the x squared, I get negative 2x squared. And then that's a positive 2x. And then if I minus 4, I get positive 4. And then don't forget that you are squaring this. Okay, and then go ahead and put it in your calculator. Oh, I get 32.4. It's not an approximation. It's an exact value. Since it's volume, these are cubic units. It doesn't ask me for units, though, so I'm going to leave it off.